Before break, we talked about counting of atoms and balancing of equations, and I wanted to review that a little bit in the context of the law of conservation of mass. So before we get started, go ahead and write down the law of the conservation of mass, which is atoms are not created or destroyed during chemical reactions. And so basically in chemical reactions, no matter how big the bang, mass is neither gained or lost in that reaction. So for example, if I start a chemical reaction with, say, 70 kilograms of a chemical before the reaction, and then there is a big reaction that takes place when I mix those chemicals together, there should be 70 kilograms of chemical left over when that is done. Now, that could be in a gas, it could be in a liquid, it could be in a precipitate. So, you know, it could be in many different forms, but matter cannot be made or destroyed in a ordinary chemical reaction. Okay? So kind of think of it kind of like a balance, and that what's on one side must be on the other side. The way we start with that then is we want to make sure we have the same number of atoms on each side of the equation. Now this is a pretty complicated equation, but it's pretty simple by just starting at the beginning and working through the problem. So the first thing I want to do, remember, is I want to count the atoms. So I'm just going to start with sodium. So there's 1 Na on this side. And then over here, there is also just 1 Na. Move on to hydrogen. So there's 1 hydrogen there and 4 there. So a total of 5 hydrogen. Go to the other side. There is 3 hydrogen there, 2 there. So again, a total of 5 hydrogen. Now I move over to the carbon. 1, 2, 3 carbon. Go over to the other side, 1, 2, and again, 3 carbon. And now I move to the oxygen. There are 3 oxygen there, 2 oxygen there, so a total of 5 oxygen molecules. Move over to the other side, 1, 2, 3, 4, 5. So 5 oxygens on that side also. So again, they are equal to each other, which means everything's cool. So when I do this, I want to remember I can only add coefficients in front of the chemical formula in these equations. I can never add or change the subscripts. So you might want to pause the video right here and make sure you write down these steps. First of all, count the number of atoms, just like we did in the last equation. And then if I have any elements that are not equal, that's where I want to start. And remember, all I can do is add coefficient. I cannot change the subscripts. And then I need to adjust, you know, I might need to erase and make some changes to get the same number of atoms on both sides so that then they'll be equal. Okay? So let's do some examples of these. And here I have Mg plus O2, and I get out MgO. Okay, so first I want to do is I want to count the atoms. So I have Mg, I have one of those over here, and I have 1 Mg on the other side. So I'm good now on that. I have 2 oxygens and only 1 oxygen over here. So I need to change something. And what I could do is I could put a 2 here. So now I have a total of 2 oxygens on that side. But by putting that 2 there, remember I also changed that. So now I have 2 Mgs. So I need to put a 2 over here to make that equal. So now I have equal on both sides. I have a total of 2 Mgs, 2 oxygens, 2 Mgs, 2 oxygens. So we're good to go. Okay? Now, here are a couple more examples. Go ahead and try to work through these on your own. So pause the video, write these down, try to solve them on your own, and then unpause the video and I'll go through the solution. Okay, so the first one here is I have 1 Ca, 2 oxygen, and only 1 oxygen on this side. So again, I need to change something on this side. I'm going to put a 2 there. So now I have 2 oxygens, 2 Cas. Again, I put a 2 there. So now it is balanced on both sides. Okay? I'm going to make sure I have an equal on both sides. Okay, then the one down here, I have 2 nitrogen, 2 hydrogen, 1 nitrogen, 3 hydrogen. Okay, so this one's going to be a little tougher. I'm going to start off by, say, putting a 2 here. So that equals 2 of those. And then 2 times 3 is 6. So there's a total of 6 hydrogen on that side. So if I put a 3 in front of that one, that changes that to a 6. So now I have everything equal on both sides. Okay? Okay, let's do a couple more examples. Again, you'll want to write these down and pause the video so you can try to solve them on your own before you go on and get the solution. Okay, the solution on this one is there are 2 Cus, 1 oxygen, 1 carbon. On this side, 1 Cu, 2 oxygen, and 1 carbon to begin with. So the way I can start with this then is I need to, let's say, let me think about this one for a second. Probably the easiest way to do is start with the oxygen over here. So put a 2 in front of that. So that becomes 4, and that becomes 2. Okay? And so now my oxygens are balanced, but I still need to balance out the Cus. I'm going to put a 4 in front of that, and now it appears to be balanced. Okay? And again, you may remember you want to make sure you have the lowest common denominator. So if you have like 4, 2, 8, and 2, you can reduce that to 2, 1, 4, and 1. Okay, let's go ahead and do the last one here. Again, make sure you try to solve this on your own before you look at the solution. Okay, so first thing I want to do is I have 2 hydrogen on this side and 2 oxygen. On this side I have 2 hydrogen but 3 oxygens. Okay, so I can probably start off by maybe let me think here. Maybe putting a 2 here, so that's 4, and 1, 2, 3, 4 of those. And then if I put a 2 here, that gives me 4 and 4 of those. So good, yeah, balance, awesome. Okay? So, again, all I can do is add coefficients. I cannot add subscripts and so on. So if this was confusing, again, just go back to the beginning, try watching it again, or come see me and I will try to explain it a little bit more detail. Thank you so much.